Hi, I'm Miss Hearn. Let's get started. In this video, our objective is to solve an application involving a geometric sequence. We're asking the question, when dropped, a ball rebounds to 1/8 of its original height. How high will the ball rebound after the fifth bounce if it's dropped from the height of 32 feet? We're going to work this problem several ways. First, I'm going to say, okay, on the first bounce, what's 1/8 of the original 32? Of always translates into multiply. So 1/8 of 32 is 1/8 times 32. Now I'm not going to work that out, but continue and say whatever that number is, then on the second bounce, we're going to have 1/8 of that number. In other words, that's going to be 1/8 times 1/8 times 32. And then on the third bounce, whatever that result was on the second bounce, however high it went, we want 1/8 of that. 1/8 of 1/8 times 1/8 times 32. In other words, that's going to be 1/8 multiplied by itself 3 times 32. And we're going to continue in this way. So the fourth bounce is 1/8 of that, which is 1/8 times 1/8 times 1/8 times 1/8 times 32. And then on the fifth bounce, we want 1/8 of that, which is 1/8 multiplied by itself 5 times and then multiplied by 32. So plugging that into your calculator, this turns out to be approximately 0.000976563. In our My Math Lab homework, we want the nearest fourth decimal place, but you'll notice that in the fourth decimal place we have a 9, and the next one over, the fifth, is if it's 5 or higher we have to round up. So the 9 actually rounds up to a 10. So we're going to have 0.0010 feet. For a lot of people, looking at this problem with the 1/8 bothers them. So let's also think about it a different way, which is that 1/8 is actually the decimal 0.125. So if you want to think of 1/8 as 0.125, then after the first bounce, we have 0.125 of 32, so 0.125 times 32. After the second bounce, we have 0.125 times 0.125 times 32, and so on. And so in the end, we actually have 0.125 raised to the fifth power times 32, which comes out to be the same result we had when we did this with fractions. And then finally, we're going to look at one more approach, which is the more advanced approach involving geometric sequences. Instead of working it out all the way to the fifth bounce, we're going to think of the first bounce as the first term in a sequence. So a sub 1, remember, was 0.125 or 1/8 times 32. And a sub 2 was 0.125 times 0.125 times 32. And a sub 3 was 0.125 times 0.125 times 0.125 times 32. And in each case, if you write this in exponential form, you'll notice that a sub 1 had a 0.125 to the first power. A sub 2 had a 0.125 to the second power. A sub 3 had 3 copies of 0.125 or 0.125 to the third power, being multiplied by 32. When we have this pattern where we're multiplying by the same value over and over again to get the next term in the sequence, that value is called a common ratio. And you know you have a geometric sequence. And so we don't need to actually work out every single term in the sequence. We can establish a formula. So using this common ratio, we continue the pattern. A sub n, the nth term in the sequence, is just going to be 32 times 0.125, the common ratio, raised to the nth power. Again, because the subscripts, which tell us the term of the sequence, match up with the exponent on the common ratio. Since that happens in each particular case, it happens in the general case too. So the common ratio 0.125 will be raised to the nth power when we're talking about the nth term in the sequence. In the case of the fifth term then, 32 times 0.125 to the fifth power, and in our example, the height of the fifth bounce of the ball in feet. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students to find the video.